In this short video, I'm going to introduce the theory to lesson 6, and we're going to be looking at oxidation and reduction reactions. So you should have your new materials booklet open at lesson 6, which is on page 15. And I'm just going to talk through these ideas of redox reactions and how that involves oxidation and reduction reactions and what they are. So just follow along on page 15. I'm just going to go through this on a blank slide. So in this lesson, we are going to be looking at reactions that can be classified as being a redox reaction. What does that mean? Well, a redox reaction is one in which reduction and oxidation occurs simultaneously at the same time and in the same reaction. But what do these words reduction and oxidation mean? Let's start with the term oxidation. Oxidation is when a substance, a reactant, something reacting, gains oxygen during a reaction. So when a substance gains oxygen during a reaction. So oxidation, as the name suggests, is the gain of oxygen to a substance. But what about reduction? Well, reduction, it turns out, is the exact opposite of oxidation. Where oxidation is the gain of oxygen, reduction is the loss of oxygen. It's when a substance in a reaction loses oxygen during that reaction. So let's recap. Redox is when reduction and oxidation occurs simultaneously at the same time in the same reaction. So you've got reduction and oxidation taking place. Reduction is when a substance loses oxygen. Oxidation is where a substance gains oxygen. That's all written at the top of page 15, but if you find that diagram helpful and want to colour code it, then you may want to pause the video and take that down. So it's important that you know the terms redox, reduction and oxidation and what those mean in terms of the gain or loss of oxygen to a substance during a reaction. So some of the reactions that we looked at in lesson 4 and lesson 5 were redox reactions. We're going to look at an example of one now, and then we're going to take a look back at some of the reactions we looked at in previous weeks and see if we can identify where the reduction's happening, where the oxidation is happening, and how overall that is a redox reaction. So let's have a look at this example of magnesium reacting with copper oxide. You can see from the word equation and the balance symbol equation underneath that when magnesium reacts with copper oxide, the magnesium steals the oxygen away from the copper oxide and you're left with magnesium oxide and copper. That happens because magnesium is more reactive than copper. It's higher than copper in the reactivity series. So let's have a look at what happens to each individual reactant. If we start with magnesium, we see that magnesium has changed from magnesium to, on the right hand side, it has now become magnesium oxide. What do you think it's done in terms of gain or loss of oxygen? Well, we can see that the magnesium has gained oxygen. So what type of reaction do you think that is? Do you think it's reduction or oxidation? Well, if we look at our definitions above, oxidation is the gain of oxygen. And so magnesium, we say, has been oxidised. It undergoes oxidation. So the process is oxidation, but we say that the magnesium has been oxidised. And you might want to highlight those in your particular colours that you've used for oxidation. So magnesium has gained oxygen, and so we say that magnesium has been oxidised. What about the copper oxide? We can see that copper oxide is our other reactant. Those are the things on the left-hand side of the equation, the things that react together. Copper oxide, we can see, becomes copper. And we said that's because the magnesium steals away the oxygen. So we can see it goes from copper oxide to copper. So what's happening in terms of oxygen? We can see that it is the loss of oxygen. So if we look at copper oxide, we can see that on the right-hand side, it has then lost oxygen. What is the loss of oxygen? Is it oxidation or is it reduction? Well, we can see from our definitions that this is a reduction reaction. So copper oxide has undergone reduction And if we look at the sentence down below, we can see that we refer to this as the copper in copper oxide has been reduced. So the copper in copper oxide has lost oxygen, and so we say the copper oxide has been reduced. So magnesium, oxidation happens to it. Copper oxide, reduction happens to it. And because we have oxidation and reduction happening in the same reaction, then this overall is a redox reaction. And you might want to write that at the side of those two sentences. What you can see in the little diagram below is that we've just summarised that information, and we've drawn a diagram that is very similar to the one that the annotations that I've made to your equation above. We can see that if we look first of all at our magnesium reactant, the magnesium has changed from magnesium on the left hand side, and it has produced magnesium oxide on the right hand side. So we say oxidation has happened to the magnesium. Why? Because it has gained oxygen. What about the other part of the equation then? Well, our other reactant is copper oxide. So we look at what happens to our reactants, the things on the left-hand side that we start with. The copper oxide then loses oxygen and forms copper. And that is what we call a reduction reaction because it has lost oxygen. What we'd like you to do now is to complete this homework task before moving on with the rest of the lesson. So this is just part of your classwork for today. So what we want you to do is to go back to the mixtures that we investigated last week where a reaction occurred, not the ones where a reaction didn't occur because the metal we added was less reactive. So for mixture 1, mixture 3 and teacher demonstration 1, and you can find what those mixtures were on page 13 of your booklet. So you'll see that mixture 1 was iron and copper oxide, mixture 3 was zinc and iron oxide, and teacher demonstration 1 was zinc and copper oxide. So for each of those mixtures, you'll have 3 examples. You need to state what has been oxidised and what has been reduced. So if I went up to the previous example that we've just covered together, you would write sentences like this. So we can see from our diagram that magnesium has been oxidised and that the copper in copper oxide has been reduced. So that's all we mean by state what has been oxidised and what has been reduced. Then you also have to draw diagrams like the one above, and that's this diagram here, to summarise the oxidation and reduction processes. And to be honest, it's probably easier to do that first because that will require you to write out your word equation, which if you're struggling with the word equation, look back at page 14, as you should have written word equations for each of those reactions on page 14. So I would actually say do this first, draw your diagrams using your word equation, and then state what has been oxidised and what has been reduced. That's probably the easiest thing to do. So what you need to do is complete this on file paper. There's not enough room at the bottom of page 15, and that will be part of what you need to submit for this week's work. If you need to go over any of that again, please go back and replay parts of the video just as you need. But complete that task and then follow the rest of the instructions document for today as we move on to page 16 and 17.